All right, hi class. So today we're going to be taking notes on 6.6. We're going to be scaling up shapes, whether they're 2D or 3D. So there are these three friends who entered a sandcastle contest being sponsored by their local radio station. The winning team gets a private beach party in a local resort for all of their friends. So to be selected for the competition, the team has to submit a drawing of their castle and verification that the design fits within the rules. So the three friends plan to build three identical castles, each one being twice as big as the previous one. They hope that replicating the same design 3 times while paying attention to the tiniest little details will impress the judges with their creativity and sand sculpting skill. So the judges require participants to answer 2 questions before building their sandcastle. What is the total area of the footprint of the planned sand sculpture, and what is the total volume of the sand required to build the sand sculpture? So the friends have only designed one of the castles, since the others will be scaled up versions of this one, each one being, remember, twice as big, right? That's important to remember. So after studying the diagram, Benji said, which is one of the friends, I calculated the area of the footprint of the smallest castle to be 3 feet squared. So then he says the next one will then occupy 6 feet squared, and then the largest will be 12 feet squared. The reason he's coming up with these is because 3 times 2, which would be twice as big, would be 6, and then 6 times 2, which would be twice as big again, would be then 12, which is then a total area that he would be using for the 3 sandcastles as 21 feet squared. Okay, what we're going to be doing is we're going to be seeing if he is correct in this statement. So our first problem says to draw 2 different shape diagrams that could represent the 2-dimensional footprint for the smallest castle that has an area, remember, of 3 feet squared. And we need to label our side lengths on the diagram. So let's make 2 different shaped footprints. So our first footprint we're going to make is going to be a rectangle, and the other footprint we're going to make is going to be a triangle. Okay. Now we have to figure out, okay, well, what are the dimensions then of these 2 footprints so that our area is 3? So some of you might have already been thinking of this. And so for the rectangle, oops, I am still using shapes, so I don't want to do that. All right, so then we have our length here of 3 feet, our width then of 1 foot. When you get the area of a rectangle, obviously it's length times width. So 3 times 1 is going to give us the surface area of 3 feet squared. Okay, and we're going to do the same thing over here with our triangle. So remember, to get the surface area of a triangle, you have to do 1/2 base times height. So our height is right here, this dotted line that I just drew in. And if we say that our base is 3 and our height is 2, if we multiply that base times height, we get 3 times 2, so 6. And if we multiply that by 1/2, we get 3. So once again, if these are our dimensions, then our surface area, like I said, would be 1/2 times our base of 3 times our height of 2. So our surface area, once again, is 3 feet squared. Okay. Moving on. So those are the smallest footprints, okay, in 2 different shapes. So if the 2-dimensional footprints you drew in question 1 are scaled up to be twice as big, so remember, twice as big, what are the new dimensions of the footprints and the new areas? So we want to get the new dimensions as well as our new areas, okay? So let me get rid of that real quick, and let me put in our 2 shapes. Now, even though we are scaling up, because we don't have a ton of space, I'm going to make the shapes look like they are the same size about, but the dimensions are obviously going to be different. Okay, so if we make these twice as big, what we're going to do is we're going to take the length and the width, or the base and the height, and we're going to multiply them by 2, right, to make them twice as big. So if we take our rectangle, and we take that length 3 and multiply by 2, you get 6. So we get, I did it again. And then we get 6 feet for length. And our width, our original width is 1. And so 1 times 2, if it's twice as big, would be 2 feet. And so then our surface area is going to be 6 times 2, so then we get 12 feet squared. Remember, for area, you want that units to be squared. For volume, which we'll get to here in a minute, we want our units to be cubed. All right, so then when we go over here to our triangle, our base, instead of being 3, it's going to be 3 times 2, so our base would be 6, and our height, instead of being 2, would be 2 times 2, which is 4. So then once again, to get our surface area, we're going to do 1/2 times our base of 6 times our height of 4. And we are going to get 1/2 times 6 is 3. 3 times 4 is going to be 12 feet squared. So we can already see that if we look up here, Benji said that our medium footprint is going to be 6 feet squared, and it's not 6 feet squared, it's actually 12 feet squared, right? So you're not just taking your original area and multiplying by 2 if it's twice as big, okay? So that is not what is happening. So we want to figure out, well, what is happening here, okay? So was Benji correct in when he says that the medium castle will have an area twice that of the smallest castle? Explain why or why not. So I am going to show you what math is going on here. So for our original surface area, right? So for our original surface area, what we did with the rectangle was we said that our area was 3 times 1, so 3. And our new one, which remember had our dimensions which was twice as big, so we multiplied the dimensions by 2. So our new surface area here is going to be 3 times 2 times 1 times 2. So that is going to give us a surface area of 6 times 2, which is 12 feet squared, right? Notice that we not only multiplied by 2 once, but we multiplied by 2 twice, right? So we have this 2 that we multiplied by and this 2 that we multiplied by. So technically what we did was we multiplied by an extra 2 squared. Okay, so if we take our original, here, let me use a different color so you can see. So if we took technically our original surface area and we then multiplied by 2 squared because we multiplied by an additional 2 2's, then we would get 2 times 2 is 4. 4 times 3 would then give us 12. So that would be just a shortcut here. Let's make sure that that shortcut works for the other figure. So for our triangle. Okay, so if we look at the triangle, so once again, we have our surface area of 1/2 times our original base, if we look up here, was 3 and our height was 2, right? So base of 3 times 2, which is going to give us 3 times 2 is 6 times 1/2, once again, would be that 3 feet squared. Forgot to put those units up there. And our new surface area is going to be 1/2 times, well, we had 3 times 2 times 2 times 2 because we took the base and multiplied by 2, and we took the height and multiplied by 2. And this comes out to being 1/2 times 6 times 4, which gives us 1/2 times 6 is 3. 3 times 4 gives us that 12 feet squared. So we're not just multiplying once again by 1 2, we're multiplying by 2 2's because we are increasing or multiplying the length and the width or the base and the height by 2. Okay? So we can write our answer here and say no, right? Was he correct? No. So changing the dimensions by a scale factor of 2 changes the areas by a scale factor of basically 2 squared, which is equal to 4. Okay. All right. Let's go on here. So let's add a third dimension to the footprint you created and make the smallest castle have a height of 2 feet. So now moving forward, we're going to have a 3-dimensional figure, and to make this a little more simple, we're just going to deal with the rectangle. And we're going to make that a 3D shape here. So what is the volume of then the smallest castle? So let's make our drawing. So as best I can, I'm going to draw this 3D shape. All right, so let's start again by marking up the length, the width, and then the height. So we have our length of our smallest one is going to be 3 feet, right? And remember, our width is going to be 1 foot. And they tell us that our height, right, it has a height of 2 feet. So that's going to be 2 feet here as our height. Okay, now in order to get the volume of this rectangular prism, we're going to take the length times the width times the height. Okay, so our volume, once again, remember from last class, length times width times height. Now, what you're basically doing is you're getting the area of the base and you're multiplying it by the height. Now, the area of the base here is obviously going to be just length times width because it's a rectangle. Now, if our base was a triangle, remember this would be 1/2 base times height of the base of your the base, which is a triangle, and then times your height, however high the prism stands, right? All right, so to get our volume here, we're going to plug those values in. So we have 3 times 1 times 2, 3 times 1 being 3, 3 times 2 being 6. So our volume here is going to be 6 feet cubed. Okay, so if the smallest castle is scaled up by a scale factor, so we have our scale factor of 2, once again, what is going to be the new volume? Okay, so let's see if something similar happens to the volume as what happened to the surface area. So I'm going to make one more quick drawing here. So let's draw this rectangular prism once more. Okay. Okay, so here it says that our scale factor is once again going up by 2. So if we take the length, the width, and the height and multiply by 2, we're going to get 3 times 3 for length. So that's going to be 6 feet. For the width is going to be 1 times 2. So it's going to be 2 feet. And then if we take our height of 2 and multiply that by 2, we get 4 feet for the height. Okay, so then our new volume is going to be obviously length times width times height. So that's going to give us a 6 times 2 times 4. And so our volume is going to be 6 times 2, which is 12. And then 12 times 4 gives us 48 feet cubed. Now remember, with volume, our units are going to be cubed instead of squared like it is for surface area. So now another thing that you can think about here is that what we did when we scaled up was we multiplied for the length here, we multiplied 3 by 2, and we multiplied 2 by 2, and we multiplied 1 by 2, right? So we added a 2 times 2 times 2. So instead of just multiplying the original volume by 2 once, what we did was we multiplied by 2 3 times, which means that we multiplied our original volume by 2 cubed. So in other words, what we did was we took that original volume. So remember, our original volume was equal to 6 feet cubed. And we added a times 2 times 2 times 2, right, for the length, the width, and the height, right? So we can also write this as our new volume as 6 times 2 cubed, right? 2 cubed is 8. 6 times 8 is going to give us 48 feet cubed. This is an easier, more shortcut way to think about how to scale up surface areas and then also volumes. Okay, so remember, for surface area, you're only taking 2 dimensions, right? Because it's 2-dimensional, and you're multiplying by whatever scale factor it is. And for volume, you're scaling up 3 dimensions, right? So length times width times height by whatever scale factor you're increasing by. Okay, so for this example, it's scale factor of 2. So we have that additional 2 cubed that you're multiplying your original volume by, all right, to get your new volume. So our number 6 here says, what would the new area of a 2-dimensional footprint and the new volume of a small sandcastle if it is scaled up by a scale factor of 3? So we have a scale factor of 3 now as opposed to a scale factor of 2. Okay, so if we think about this the way that we were thinking about our shortcut, if we take our 2-dimensional footprint, so that's talking about surface area, right? So if we take our original surface area and think about what that was, so let's remember our original surface area was 3, right? And we're scaling up by a factor of 3. Let's do just a quick picture here. So our original length was 3. So if we take 3 times 3, we get 9. Our original width was 1. So 1 times 3 is going to give us 3. We know 9 times 3 is going to give us 27. So I just did a quick picture over there on the left. But if we do our shortcut here, basically what we did was we took our length and our width and we multiplied by 3, right? And so if we take 3 times 3, which is also known as 3 squared, and multiply that by our original surface area, then we can get our new scaled up surface area. So let's go back to our problem up here, which I was starting to write. So all I wrote was surface area is equal to 3 because that is our original surface area. And what we're going to do is we're going to multiply that by, because we have our scale factor of 3, it's going to be multiplied by 3 squared, right? For the 1 and 2 extra 3's that we multiplied by. Okay, so our new surface area is going to be 3 times 9. So our surface area is equal to 27 feet cubed, which is what we got in our picture over here to the left, right? If you just scaled up the length and the width, okay? Now, if we take this logic into looking at our volume. Remember, our original volume was 6 feet cubed. And if this is a scale factor of 3, remember, we're going to multiply the length, the width, and the height by 3. So that's going to be 3 times 3 times 3. In other words, 3 cubed, right? Length times width times height. So 3 threes being multiplied together. So our new volume is going to be 6 times 3 cubed. So our new volume is going to be 6 times 27, so 162 feet cubed. And you could definitely do a drawing here if you wanted to. Okay. What would be the new area? So now we're just going to be practicing all of more problems with different scale factors. We're still going to be thinking about just that rectangle, okay, just to keep things pretty easy here to start. So what would be the new area of the two-dimensional footprint and the new volume for the small sandcastle if it was scaled up by a scale factor of 4? Okay. So let's talk about our surface area over here and our volume here. So remember, our original surface area was 3 feet squared, right? And what we're going to be doing is we're going to be taking our length and our width and multiplying by 4 for each. So that's an additional 4 times 4. So an additional 4 squared, right? If you want to think about this in terms of a picture, we're taking 3 times 4, so 12, and 1 times 4, which is 4, right? So then you would take 12 times 4 and get 48 feet squared. So that would be if you're looking at a picture. And if you're just doing this algebraically, you could think about it as 3 times 16. And once again, you get 48 feet squared for your surface area. So that's our scaled up surface area. Now volume, remember our volume of our smallest sandcastle was 6 feet cubed. And since we are scaling up by a factor of 4, we took the length, the width, and the height and multiplied by 4. So that's 4 multiplied by itself 3 times. So instead of putting 4 times 4 times 4, we're going to put times 4 cubed. Okay. And this volume would then be 384 feet cubed. Okay. If you know the area and volume of an object, explain how you find the new area and volume if the object is increased by a scale factor of x. Okay. So the area, so let's just put this down here. So the area increases, so this is area we're talking about, not volume. Oops. So the area increases, oops. Sorry about that. So the area increases by a multiple of x squared, right? So you'll notice up here so whatever our scale factor is, right? Our scale factor is x. So up here in number 7, our scale factor was 4. So that's going to be 4 squared. In the problem right above it, number 6, you can see that our scale factor is 3. And so it's going to be 3 then squared. If our scale factor was 5, it would be times 5 squared. If our scale factor was 100, it would be then 100 squared, right? And then let's talk about volume. So then the volume increases by a multiple of x cubed. So if we look at our problems previously here, so our scale factor is 4, so we're going to be multiplying by then 4 cubed for number 7. And then if you look right above it at number 6, our scale factor is 3, so we're going to be multiplying by 3 cubed. If it was a scale factor of 100, it would be multiplying by 100 cubed. Okay. So this next page is just some quick practice here. It says find the scaled up base area and volume of each of the following three-dimensional shapes with the given scale factors. So once again, we have a rectangular prism. We have our base area of 20 and our volume of the entire figure being 140 centimeters cubed. So we have to find our base area after we have over here on the right hand side, it says a scale factor of 2. So if we started with 20, right, 20 centimeters squared for our base, and we have a scale factor of 2, and we're looking for area, right? Our scale factor is going to be then squared. So 20 times 2 squared. 2 squared being 4. So this is going to end up being 80 centimeters squared. Now let's just go right down below where it says scale factor of then 3. So same idea. We start with our original area of 20 centimeters squared. And since our scale factor is now 3, it's going to be multiplying by 3 squared because we're multiplying, right, the length and the width both by 3, right? If it's a scale factor of 3. 3 squared being 9. 9 times 20 would give us 180 centimeters squared. All right. Now, when we talk about volume, which is that far right column there, when we're going up by a scale factor of 2, you want to take your original volume, which we can see here is 140 centimeters cubed, and we want to multiply that by now our scale factor cubed, right? So remember, if we go back up here, let me just put what we learned up from up above. So for area, you're going to take your scale, multiply by your scale factor squared. And for volume, you're going to be taking your scale factor cubed, right? So back down here, instead of multiplying by 2 squared, it's going to be times 2 cubed because we're now looking at volume, right? Which is going to then give us a new volume of 1,120 centimeters cubed. And if we have a scale factor of 4, once again, we start with our original volume of 140, and then we're going to multiply by then 4 cubed instead of 2 cubed. And that's going to give us a new volume of 8,960 centimeters cubed. Now, I'm going to give you guys just a moment. I would say to pause the video and see if you can do the next 2 problems before watching and seeing what the answers are, just to see if you can do them on your own before moving on to the practice. All right, so for this next problem, we have a scale factor of 2. Our original area is 7. And we're increasing by a scale factor of 2, so multiplying by 2 squared, which would be 4. So this is going to give us a new surface area of 28 inches squared. Now, if it's a scale factor of 4, once again, we start with our original surface area of 7, multiply by then 4 squared, which is 16, and that's going to give us 112 inches squared. Now, if we move over to volume, remember you're taking the scale factor then cubed. So our original, notice our original volume here on the left is 35 inches cubed. So we're going to take 35 times 2 cubed, and that's going to give us a new volume, of 280 inches cubed. And then our scale factor of 5, remember we start with our original volume of 35, and we're going to be multiplying by our scale factor cubed, so our 5 cubed. And that's going to give us a new volume of 4,375 inches cubed. All right, and then for our last one, notice that you don't even really need a shape, right? Because you see that little question mark there. It doesn't really matter. All you want to know is your surface area, right? And then your volume. And then you can just scale it up or down, however you need to. So for this last one, our original area is 32 meters squared, and we are scaling up or down actually by half. So we're going to take 1/2 and we're going to square it, right? So technically we're multiplying 32 by 1/4, or taking 32 dividing by 4. And this is going to give us a new area of 8 meters squared. And that's the only problem here. And then if we have a scale factor of 1/2 for the volume, we're going to start with our original volume of 320 meters cubed, and we are going to multiply that by 1/2 to the third power, right? And that is going to then give us 40 meters cubed for our new volume. All right, that's it. Thanks so much.